My next question for you is, how do you as a mentor approach helping your peers advance their careers in computational modeling and biomedical engineering?
Sure. So during like over the last few years, I have gotten the opportunity to work with 3 or 4 juniors, and I'm very happy to say they're also women in STEM and in my field. So first opportunity was 2 years ago. I was working with a student back in India. I was in Boulder. So they were interested in working with our research lab in University of Colorado Boulder in the US. And that time they couldn't be here in the US and work with us in person. So I got the chance to mentor them online. So it was like a virtual internship for them, and I handled the guidance and mentorship part aspect of that. So yeah, like the girl I mentored, she is a very bright and very intelligent person, and she was working on a multitude of projects and had a little bit of a, I would say, a little bit hard time managing those projects. So many a times we spoke, and sometimes I was able to give her good tips and help her navigate in her projects. But I'm very glad to say that now she has started her higher education at a very at an Ivy League college in the US. So I feel very happy to have been a part of her journey and to have been like mentoring her through this. So it brings me a lot of joy and a lot of a sense of pride, basically. So that was one person, and then I had another junior of a different ethnicity than mine, and again, like at that time, she was in her undergrad, and I was in my master's. So yeah, like for this other junior, I mentored her in designing models of blood vessels in our body. So we use specific softwares and specific tools to design or like create 3D models of blood vessels. Oh, just give me 1 second. Okay, sorry, my Alexa has gone on. Sorry about that. Yeah, to continue. Yeah, so the girl I was mentoring, I taught her how to create 3D models of blood vessels, and then like I also taught her to how to simulate blood flow inside those vessels. So teaching her some basic principles of fluid dynamics, and then computational fluid dynamics, and also like what are the best practices to create good 3D models which can be used in research. So she's again doing very well. Currently, she's about to graduate, and she will be pursuing her research interest in biomedical engineering. So again, I feel a very proud mentor to have been in a part of her journey. And then again, like there were a few more people who I got the chance to mentor, and very happy to see them all growing and all like shining in their fields. Again, I want to add that before this, someone very nice and very talented mentored me. So I felt very, very privileged to have her as my mentor here when I came first to CU Boulder. And with that, I wanted to pay it forward. So that got me into this mentorship and guiding my juniors thing. So yeah, I always like to say that whenever something good happens to you, just pay it forward, and you will see all nice things happening, and like everyone will be happy, and that will in turn make you happy. So always, like in your careers, always take a chance to have a good pause and see if others around you are also growing. You know, like many a times we get so busy in our own personal growth that we don't stop and see if our peers and our juniors or like people around us in general, how they are doing. And if we can, in our whatever, like in our small way, help make a change in their life, we should always take that opportunity and try to help them. So that's basically what mentors do. And even as mentees, you can help your mentors. So all of my mentees, they help me a lot. Like I got to learn a lot of things about myself while mentoring them. So I would say in your future, or like even like you must be mentees, you must have mentors. Always maintain that relationship, and that will go a long way forward.
Thank you so much, ma'am. To have a mentor like you who will connect to us is both soulfully and tech, like with all the studies as well, would be like wow. And
I always there. If you want to reach out to me, reach out at any time. I always welcome questions.
thank you so much, ma'am. Most of the people don't really respond to our emails, but you went out of our way to check the documents and replying. That was also very heart touching, to be honest.
Oh.
And to move towards our next question, I wanted to ask you, with all while being busy with your own work, how exactly do you stay up to speed with the most recent studies of advancement in the domain of fluid dynamics and cardiovascular modeling as an engineer working on a biomedical applications? Like it is certainly tough because you already have a lot of work by yourself, and having to deal with new research as well is must be hard.
Yeah, it is challenging, and yeah, like these are like tough big words. I can totally understand. So you don't need to like go all the way and like say the full forms, but yeah. So as scientists, as engineers, we keep up to date with the new research by reading journal papers. So there are big so-called like societies or groups of well, like seasoned professional researchers, professional like big scientists, big names who are involved in these publishing houses, and in each field they have like publishing, like places where papers come from, basically. So research journals. So we call them research journals. So we keep up to date by reading publications from those journals. And it's very important as scientists, as engineers, to be up to date on reading new advancements in our field. So we use Google Scholar a lot. Google Scholar is Google search, but for science. So if you want to find out that uh, a certain idea that you have, whether it has been worked upon before, you can search on Google Scholar and you will get people's research theses, and like a research thesis. I don't know if thesis is a word or not, but yeah, research thesis, then manuscripts, and there many a times they publish all their project there, or even like what do you call it? I'm again forgetting the word, but like people also publish about designing new devices. So that is there as well. So you can find a whole big like world of exciting things at Google Scholar. So we use that a lot and keep up to date with the latest research. And yes, while working on our projects as well, we build on the shoulder of giants. So those giants are people who have worked in our field before. So we use their work as a basis to develop our own research. So every day I read a paper at least, one paper at least, if not more. So that helps me to, first of all, learn how someone approached a particular project or approached a particular idea. Learn from their experience and learn from whatever limitations they found in their research and try to mitigate that in my own research. And then secondly, it brings the excitement also, like to see, oh, if I work in this project, I might get results similar to what this particular person achieved. So seeing someone else's work, you also get very excited to pursue your own work. So these two aspects are what keep researchers going in their fields. So reading papers, reading new publications are very, very important for us. And that's how we keep up to date. Another way we keep up to date is by going to conferences. So that is a very big opportunity for all scientists, engineers, researchers to meet new people in their field and interact with them, new research groups or like other research groups which you might not have heard of. So you go to the conferences and meet those people. You also present your research, but you also get to know other people through that. So that is also a very big part of being a scientist.
Ma'am, you mentioned about Google Scholar. Even I use that. It helps me know more about female scientists and it gives me motivation. As a student pursuing medical as well, I find it really challenging to become I'm a NEET aspirant and
Okay.
it's a little scary for me. I have to strive really hard if I want to become a doctor, and seeing so many women scientists on Google Scholar keeps me motivated.
Yeah.
My my next question for you is, have you ever had to push yourself to overcome a new engineering challenge? If so, how did that go for you?
Yeah, many times. Many times, basically, like most of the projects that I worked on were something that had never been worked on before or were very new, like they were new questions. So starting from this project that I did on left ventricular assist device and its effect, like the heart pump that I worked on, its effects on the blood flow inside a heart failure patient's body. So that project was quite fresh. It had not been worked before much. And by the research I did with my advisor, we opened like a big whole chapter there. Like we were able to ask many questions, resolve many questions, and like uh, show what could be done with computational fluid dynamics. So big challenge there was to get they were like to get patient data. So it's very hard to get patient data for your research, and only like it goes through a lot of protocols and only specific research institutions have access to it. So for me, in my research group, although I did not have to deal with it myself per se, but like that was a big challenge, getting patient data for my work. And then again, like understanding. So I was from an engineering background. After my high school, I did not touch biology books at all. maybe I had a little bit of exposure to some physiology in my first year of undergrad, but nothing after that. So no studying of anatomy or physiology after my first year of undergrad. So that was a big challenge to learn those things from scratch, learn about the anatomy, then learn about how things happen inside the body, because it's a whole machine itself, right? It's a machine that still people are like so many people are working on understanding, and like I'm also working on understanding how the body works. So yeah, that was again a big challenge, learning bio, being from a science background, from an engineering background. So yeah, like I would say these were the big major challenges, and up like still to date, I uh, face some of these challenges because I'm working in cardiac surgery department as of now, and we have a lot of uh, like abnormalities. Like we come across a lot of abnormalities in children, different kind of heart defects, different kind of uh, 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 problems that these kids are facing. So with the help of uh, uh, like my mentors at my current position, I'm able to learn about these fields and try to use my background in fluid dynamics and apply that into those fields. So yeah.
That I totally relate with your struggle. Even I am studying about the circulatory system at this age, and you had a very less amount of time to learn so much. I was studying about heart today. I myself got a myocardial infarction reading about it.
Yeah, it is. It takes some time to get there, but yeah, I'm fully confident that you will be very good at whatever you want to pursue, be it NEET or any other field that you want to pursue. Just give it all the time and energy you can.
Thank you so much, ma'am. My next question for you is what potential developments or innovations do you foresee occurring in the field of cardiovascular modeling and patient specific stimulations over the next few years?
Yeah. So firstly, it's there are two different things. Simulation is different. Stimulation is different. I would like to interject there and correct you. So simulations is basically uh, uh, reenacting something happening inside the body. So like if I talk about biological simulations, so you are recreating something, like you are recreating the blood flow that happens in the body, but in on the computer. So that's called a simulation. Stimulation is something that like you like generate a stimulus, right? Like you generate a stimulus and see for a like check for a response. So like those are different things, but I don't know a lot about generating stimulus, so I can't talk about that. But yeah, about simulations, new things that are coming would be so big companies like Autodesk, Dassault Systems, they are working on a project called the Living Heart Project, where they have taken data from like a lot of big hospitals. One is the place that I'm working with, Boston Children's Hospital. Then there are many big institutions in the world that they are uh, working with to collect all different sorts of patient information on heart diseases and heart defects. So what they will do is they will create a digital twin of the heart for a normal body as well as the diseased body. So digital twin is something that happens, like say I'm a person, but I have a digital twin of me on a computer. So whatever is happening inside me, it will happen on the computer as well. So that is like a digital twin. So with the advent of AI, with the advent of new technology, uh, we will in our near future we will see something like this come into action. Like, say a patient is there who like who is if I want to talk about a heart disease patient and they are in a critical condition, you do not have the time to like work on creating models for them and creating CFD simulations for them, because this takes a lot of time. Like if I work on a patient and like if I create a whole like 3D model for them and then like simulate blood flow in their body, it takes at least, I would say, a week to do this. But in critical situations, you don't have that much of time, right? So using probes and sensors, you can connect their body to a computer and have their functions replicated on a computer. So that will help you see what's happening inside the body. And doctors will be able to make decisions very quickly. So that is the next big thing that I foresee will happen. And like I have, so like health issue detection or like uh, uh, things that you have, like your smartphone and like these devices that we use every day, they can like we are still seeing this. Like as of now, we are seeing this that these can be used to detect abnormalities. Like Apple Watch helps to detect like many a times it helps to detect missed beat of the heart. So like that, the whole body can be monitored using these devices. So I very much foresee this happening, and in a very like near future. Not even like I'm not even talking about 50 years uh, uh, later. It's like within a decade this will happen. So, and you
Um,
guys will be leading it.
I had a follow-up question. So I was studying about cancer and tumors today, malignant tumor and that. I have heard about tumor in every other body part except heart. Like, why does not it, like, I have not heard the term heart tumor anytime
That is
before.
a very interesting question.
So why is it that is then like a tumor cannot be found at the heart or formed at the heart?
So I don't know if I know the answer to that question. It's a very interesting question. I have not thought about it, and you should definitely like search more on this. But in the heart, most diseases they happen when the blood is not flowing well, and if it stays at one place for a long time, then it tends to clot, and those blood clots get stuck in other parts of the body, and they can cause, like if a clot gets stuck in the brain, it causes stroke. So those kind of things are related to the heart. In the heart muscle, uh, uh, the surface, like the blood vessels and like the muscles of the heart, they can also be damaged in particular ways, but I'm not sure if tumor as such happens in the heart. Definitely disease of the heart muscle happens when it like becomes stiff and they can't pump any longer. That happens. And then vessels get diseased many a times. But tumor is something, correct me if I'm wrong, but aren't tumors something where the cells of that particular organ are they start going out of hand and like generate multiple copies of them without like that being a natural process. Like sometimes something happens and like they will replicate too much, which is
Yes,
not
ma'am, they
in the
become
body,
normal
right?
cells of our body become cancerous. They are called neoplasm or something like that.
Ah, I see. Yeah. So that doesn't, you're right, that doesn't happen in the heart. Maybe it is regulated in some ways that those cells can't replicate beyond a point, which might be like very necessary for our body, I'm guessing. Because if that happened, then it would be another deadly thing for the body. But yeah, it's very, very nice question. You should check that out more. I will also check that out.
Sure, ma'am.